All right, hello everyone. This is lesson 23 in the science class. We are going to talk about volcanoes. And first, I would like to kind of highlight here the submission of Team Zeta. So they did caught on that we are using Greek letters here, so they had a very cool Zeta there. And so this actually is a pretty ambitious mission. Okay, so this team is going to pretty much send several probes. Okay, they are planning to actually colonize Mars and sending probes to nearby asteroids near the Mars orbit, so probably the asteroids in the asteroid belt between Mars and Jupiter. And then they would like to take some of those asteroids, put them in orbit around Mars, and mine them there in order to start creating kind of a habitable place in the Martian surface. Okay, so really a lot of good research in this project. Okay, there's a lot of good um, paragraphs written here on how Mars it probably has water in the polar caps of Mars. They have found some frozen water beneath the surface. Okay, and that could also be drilled and mined in order to start probably watering other areas and so on. So this is not one mission. This is actually a whole colonization program of that. So my only suggestion for the team would be, is there a way that you would like to probably narrow down the scope of your mission to think, okay, of sending either one probe to Mars or how you would design one probe to an asteroid? Okay, can you understand why I'm saying that this is really a large thing? Okay, because this is a whole program, and I guess that the end goal of this mission is as we expect. Let's say we expect to have humans living in Mars by 2075. Okay, about 65 years, 60 years from now. That is a very, very ambitious program actually to have. So it's a series of missions. Okay, so a very good job. I'm going to grade that soon and then give you some more feedback on that. Okay. So let's see. Today's lesson we have is lesson 23. I'm going to go there. And so the concepts for these lessons are that volcanoes demonstrate that the Earth is always changing. Okay, we are going to talk about volcanoes. Natasha says that she likes volcanoes. I would love to know why do you like volcanoes. Okay, I like them too, but they are actually also pretty scary in some cases. Okay. And then the gospel principle that we are going to talk is about how the gospel of Jesus Christ is a constant in a changing world. Okay, so the lesson also has here links to the family school. I remember that Nathan mentioned yesterday that you still don't have access to the family school online, but I requested that. Okay, and so we are going to hopefully you will have it pretty soon. We have some links here to some videos. Okay, there's one here, one link to Kaliwea Mountain of Fire video. It's actually a very cool video. It's about 50 minutes long. It's a whole episode on nature, on Mount Kilauea and the volcanic activity in the island of Hawaii. Very, very interesting, beautiful, and worth watching. Okay. I also have some videos about here how volcanoes, form and geysers. We are going to watch a couple of these now here in class. And there's two really cool websites that I want you to explore. One is on Oregon State, okay, it's Volcano World, and it has a lot of information about volcanoes and actually current things going on the area of volcanology. So this would be a very cool place for you to explore and learn more about what are the current volcanic activity going on in the world. Okay, so I really invite you to explore this website in detail. I have also here a link to Wikipedia, to the article on volcanoes. And this article is really nice, very informative. Okay, like always, Wikipedia has really, cool images and explanations of how volcanoes happen. So, what are the different types of volcanoes that are there? Okay, and where do volcanoes happen? Okay, let me see. This is the lesson in the family school online, and some links and images. This is an image of Old Faithful, a geyser in Yellowstone National Park. We're going to talk about geysers and in a little bit. Also, another thing that is very, very cool about volcanic activity is that the ashes and the lava forms new soil, and this soil, because it brings a lot of minerals, is actually very rich and very good for agriculture. So it is interesting that there's this kind of tension, if you wish, between volcanic activity and human activity, because the volcanoes always form places where people want to live, okay, even though it's a scary place. So Abigail says, volcanoes happen when two plate tectonics slide across each other and push the lava up and make a via, okay? So a via meaning a way for the lava to escape. All right. So it is true that volcanoes happen in the boundaries between plate tectonics. Okay. But what I found out is that it is not true. Volcanoes usually don't happen in areas where the plates slide across each other. Okay. So let's go back here to the Wikipedia article, all right, and it explains, okay, let's see, here in the introduction, all right, it explains the different types of volcanoes, and see here it says volcanoes usually are not created where two tectonic plates slide past each other, all right? So you have that, like in the famous St. Andreas Fault in close to San Francisco and in the area of California, where you have the two tectonic plates that actually are sliding. Okay, so you have the two tectonic plates just sliding against each other. That is not an area where volcanic activity happens. Okay, so, but it is true that the volcanoes happen in areas where tectonic plates meet, all right? And usually, like we were talking last time about the different types of plate tectonics, you have the divergent plate boundaries. Those are the areas where the plate boundaries separate. Those form volcanoes. The convergent plate boundaries also form volcanoes. And then, as Haley mentions, there's also hotspots, okay? And the hotspots are just a different type of area where volcanic activity happens, okay? And there's a different theory of how the hotspots form. So let's go here to this map that is I found there on Wikipedia. And here you can see the areas where volcanoes happen. All right, let's see if we can enlarge this a little bit more. Okay. All right. So you have the small triangles, all right, are the actual volcanoes. And then the lines are the areas where you have divergent plate boundaries. Okay, so the lines are the areas of volcanic activity of divergent plate boundaries, and the triangles are the areas where you have volcanic activity. Okay, so we see here, let's go back to the size so that we can see. Okay, here we can see the whole map. And this part, this area around the Pacific Ocean, okay, going through the Aleutian Islands, okay, North America, then Central America, okay, and the Andes Mountains, that is what is called the Ring of Fire. So because that is the area, the most active area in the world for volcanic activity, okay. There's also other areas in the world that are very active here in Indonesia, the Philippines, that is part of the Ring of Fire. You have here in the area of Africa, Tanzania, where there's a rift between tectonic plates and there's a lot of volcanic activity. And then in Europe, most of the volcanic activity is in Italy. There are some in Turkey and the Ionian Sea, and of course in Iceland. Lots of volcanic activity there in Iceland. All right. So we were talking about the different types of volcanic activity. One happens when there's a divergent plate boundary, and that is when you have the two plates that are actually separating, okay? And so the crust of the Earth is very thin in this area, usually is in the bottom of the oceans, in oceanic crust, that is very thin. Sometimes, the crust actually disappears, and so you have directly connection there between the crust and the mantle of the Earth, and so the mantle sprouts out and pushes the tectonic plates and separates those. So those are, if you wish, volcanoes that are in the mid-oceanic ridges. So it would be usually what we associate with the activity happen here in the Atlantic, that is the mid-Atlantic ridge, okay? Also here in the East Pacific ridge and the Antarctic, Indian Ocean, okay? So all this area is area where you have divergent movement and activity where the plates actually separate, okay? So these volcanoes are submerged, so we don't see them really, but you can see the effects of those. Sometimes the volcanic activity accumulates so much material that forms islands, all right? And that is where you have these little islands in the middle of nowhere, like the Galapagos Islands, okay, the San Juan Islands, Eastern Islands there of the coast of Chile and so on, and also some of the islands in the Atlantic, St. Helena, the Azores, okay, and of course Iceland was formed all through this type of volcanic activity, okay. In the Indian Ocean we have similar type of islands happening. You know, like Reunion Island is a huge volcano, really, that happens over a long time. Okay, so Madeline says, I love them. They are hard to climb, but definitely worth it. So isn't there also hotspots that create volcanoes? We are going to talk. So then we have, so we'll talk about hotspots in a minute. So we have the first type is the divergent plate boundaries. The second type are the convergent plate boundaries, and those are with the areas where you have subduction zones. Okay, so that is basically where you have the oceanic crust, okay, as oceanic plates colliding with the continental plate. You know, remember that when we talk about the tectonic plates, the continental crust is thicker, okay, a lot more solid and heavier, and the oceanic crust usually is the one that goes under and is subdued, all right, is submerged underneath, and also sometimes that is the one that pushes the continental crust higher and higher, and that is what forms, you know, mountain chains like the Andes mountains, the Rocky Mountains, that are all through this activity. So what happens is as the crust is submerged underneath, it melts, and the water, the things that form under there, start liquefying, and that produces lava, and it generates, through the pressure of volcanic activity in those areas. Okay, so that is the second type of volcanic activity, and that is most prevalent here in these areas where you have the Ring of Fire, all the volcanic activity happening around the Pacific ridge. All right. Also, that is what happens in Europe and in Eastern Africa. Okay. So that is the type of volcanoes that you have there. The third type of volcanic activity here is what we call the hotspots. Okay. And the hotspots are kind of like a mystery, really. Still, we are not sure about how is it that they form. But the examples that they have of hotspots are the Hawaiian Islands, okay, Snake River Plain, Yellowstone caldera. They are basically a type of examples of these hotspots, okay. And the interesting thing is the theory, one of the theories about these hotspots is that they form, let's see, here we go to this thing, okay. And so the article here on the mantle plume, the idea is that this is not where two plate tectonics meet. Okay, that is the interesting feature and the mystery of the hotspots is that they form not where there is a break in the tectonic plates, but the theory is that it's a heated area where part of the core of the Earth. So remember that we have the mantle. Okay, let's see if we have the picture. Okay, so we have the crust, okay, then the 3 would be here the upper mantle, the moho is the layers in between the two, and so on. And so this is the upper mantle, the inner mantle, and then you have the core, the upper core, and the inner core of the Earth. The theory is that for some reason there's some area here in the mantle that makes a fissure, all right? And so it lets some of the core material put pressure upward, and that makes the mantle also bulge and put pressure and break through the crust, okay? So if you have here a diagram, of two different liquids of different density, and when one is heated and the other one kind of starts in a convection flow, it kind of dips and it forms this type of plumes that rise the hotter material up. Okay, so that is kind of the idea of this. Let's see. How do I get rid of that? Okay, there you go. So the idea of these hotspots is that they would be plumes of core material, very hot, putting pressure on the mantle that would raise the mantle and break through the crust. Okay, and so what you have is that this core material would go through the mantle as the plate moves, so it would, as this breaks through the crust, it forms a volcano, okay, and the volcanic material spills over and forms the dome, and over time the plate on the crust moves, normally, and so the volcano would just keep moving through. Okay, and that it seems that is kind of the case on the Hawaiian Islands. I love Google Earth here, so if we go through to Google Earth, we can see, okay, what do you notice here on the surface, of the ocean, of the Pacific Ocean, as you see the volcanic activity and the islands of Hawaii. What do you notice here?
It's small.
It's small, yes. Yeah, it's relatively. It depends on what is it that is small. Okay, but what I want to, the Pacific Ocean is huge, as you can tell, it almost covers, half of the Earth. All right, you see that this whole thing, really is covering most of the, you have a whole hemisphere view, pretty much is all Pacific Ocean. So yeah, the Pacific Ocean is huge, really. But what do you see on the bottom of the Pacific Ocean's surface? What features do you see? A network, lines, okay? And can you see that there's two different types of lines? So we see these lines, okay, that are probably areas where the plates diverge, okay, that form new ocean crust. Here you see the subduction zone, where the oceanic crust goes down below the continental crust. You see how clearly that is there. Okay, and if we go back to here, the Pacific, the Hawaiian Islands, can you see the movement of the plate? So as the plate moves this way, okay, moves southeast, the islands go over the hotspot. So the hotspot of the chain of the islands of Hawaii is currently under here, under the big island of Hawaii. But can you see that it goes pretty much in line, and that shows the movement of this whole plate. So you can see the plate was actually first moving south, kind of south-southwest, and then it changed direction and started moving southeast, and that is the current direction on how the plate moves. Okay, to the southeast. And you also see, you can tell, that the speed at which the plate moves has decreased over time, because the smaller areas here of hotspots means that the plate was moving faster than the hotspot could build up a volcano to build an island. Then you see, as we enter here the area of Hawaii, let's zoom into Hawaii, okay, that the islands of Hawaii are getting larger and larger. So what does that mean? That this part of the plate, okay, of the Pacific plate, is over the hotspot for a longer period of time. Okay, so it's slowing down in its movement. Then you see how that goes through. Let's go and look more here at the island of Hawaii. This is the hotspot volcano. Benjamin lives here in the city of Hilo. Okay, and the island of Hawaii have two volcanoes. Well, two big mountains, Mauna Kea, okay, and Mauna Loa, and the active part of the volcano now is here in Kilauea. Okay, so there's a huge crater, all right, that is still smoking, the crater in Kilauea. Okay, and it's really, really cool how this dome, okay, and the crater is still quite active. There's this other area that is the most active part of the volcano. But a few years ago, in 1983, actually the volcanic activity moved to a new hotspot. Okay, so let me see if I can go over there. Okay, so it's not very far, but it's this part, okay, Puohoho, okay, Puoho, something like that. That is how it's pronounced, all right. But this area of the volcano is now active, and that will probably be forming, and it's spewing lava, all right. The lava sometimes reaches the ocean, and many times it goes over some areas that were inhabited. Okay, so yeah, so it's really, really cool. A few years ago, I don't remember, do you remember when the volcano erupted in Iceland? This was in 2010. There was a huge eruption of a volcano in Iceland. All right. Okay. So you found a YouTube video of this. All right. I invite you to look at that. Okay. Benjamin says, I live in HPP. What is HPP? Right. Rodney, do you want us to look at this video now?
You could look at it later.
Okay.
It was just like it was a close up of a volcano.
Uh-huh.
Boiling and running, and then you could see a guy in the background.
Okay.
I'm glad I didn't look at that. It was really interesting. And it leads to other videos about their expedition to that. I just wanted to show it's a little 59-second clip.
Aha. Okay. Excellent. So Benjamin is telling me that he lives in Hawaiian Paradise Park, okay, which is south of Hilo. All right, let me minimize this. So we'll watch that if we have some time, okay? So Hilo is here.
Just that it was for after class or something.
Okay. Mm-hmm. So there's a road that goes here from Hilo to Keau and then goes through Hawaiian Paradise Park. That is kind of a new development. And then they have been trying to also develop cities here in this area. So in 2010, my wife and I had kind of an interesting experience. We were going to go to London, and we were all the way in Denver in the airport. Okay, let me go and zoom out and see. So we had flown from Salt Lake to Denver, Colorado, and we were right in the airport going to fly to London. All right, I was going for a conference there. And as we were sitting on the plane basically to go to London goes through a trajectory that is about this way. So it goes from here, okay, that is the great circle that forms. So it goes pretty close to the tip of Greenland and close to Iceland. We were on the plane, ready to depart, the seatbelts on, we were looking at all the brochures and everything, the things that we were going to do in London. And the captain of the plane comes over the intercom and says that because of the volcano eruption in Iceland, it was sending so much ash over the air that they had closed all the airspace, all the flights going to Europe. Okay, so the ash, basically the problem is that if the ash gets in the turbines of the airplanes, it coats, the ash is hot and the turbines are also very hot, and the turbines get coated with this volcanic ash, and then they would start deforming the turbine blades, and they can just destroy the engine. And so the insurance companies could not guarantee the turbines surviving going through that, and so they decided to close all the airspace. I don't know if you remember that, but it was a big deal because millions of people were kind of stuck in airports and everything. It was kind of a big deal. So we were stuck in Denver. The next day we flew back to Salt Lake City. Okay. And I didn't want to just cancel the vacation, so we went to a kind of a tourist company, and we said, okay, what do you have available for us? All right. So that's that particular 5Js. Yeah. So yeah. So yeah, it was a volcano that had a kind of an unpronounceable Icelandic name. I don't remember that now. All right. And Annika says I had to write a report on it. Were you about in Europe around that time, Annika? Sam, were you around there? So the thing is that our vacation to go to London got canceled because of volcanic activity. So we went to this tourist company and we said, what do you have? We want to go somewhere. And so they said, oh, we have a vacation for you going to Hawaii. So we went to Hawaii. So we went from one volcano to another volcano. Well, we were there in Hawaii. One of the things, of course, that we visited was the National Park of Volcanoes, National Park. And we wanted to drive around all this area. So one day we got into our rental car, we went here to Hilo. We actually drove through the north part of the island. And then we drove here to this road. We went very close to where Benjamin lives. We went here to Pahoa, okay? And then as we started, there's a road that goes very close here to the ocean. And the road is a really nice road, okay? And about here, you start seeing, you see houses on the side and everything. And all of a sudden, it says, road ends in 1,000 yards. Okay, road ends in 500 yards, and then road ends, and you see a wall, literally a wall of lava that just went over the road and is about, about a meter and a half, probably about 4 or 5 feet high, a wall of lava that just went through the road and completely obliterated everything in its path. Okay, so then you can start riding your car on the lava. Okay, and you ride for a couple of miles until you get to a parking spot, and you see here the parking spot, and then you can get off the car and start walking in these trails. Okay, this one here. There are some cars that get allowed, but ours, we left ours there at the parking spot. And you get to this area that is kind of fenced off, and is an area where you can start seeing the lava flow going by. Okay, and it's so Annika says that when they live in Mexico, we drove part way up a volcano. So there are lots of volcanoes there in Mexico also. So this lava flow here in the evening, you can see actually it starts kind of, as it gets dark, you see more and more of the flow of the red of where the lava is flowing. But it was actually very close to us. Okay, so we exchanged one vacation, that was canceled for a volcano, for another vacation at an active volcano. So Benjamin asked me, "Have you been to the temple here?" Yes, we went to the temple in Kona. Okay, we were staying there in Kona, and so we went there to the Kona Temple. Very interesting area here in Hawaii. And I encourage you to look at that video on Kilauea, Ring of Fire, all the things that are going on, because this is one of the most active areas of volcanic activity in the world. This eruption actually has been going on since 1983. Okay, so let me see. This is telling me to go on or refresh. Okay, so here we were talking about the different types of volcanoes, all right, how they happen over divergent plates, convergent plates, hotspots. Okay, and Yellowstone is also one of those hotspots there. So there are lots of volcanic activity also here in southern Utah. So Jen says you have lived in Cortez, Colorado. Are there any volcanoes there? There are some volcanoes in the San Francisco Mountains, the area there in Arizona, by Flagstaff, okay, Arizona. This article, I really want you to read this article because it explains the different types of volcanoes. All right, so you have fissure vents, shield volcanoes, lava domes, cryptodomes, volcanic cones, stratovolcanoes, and supervolcanoes. Okay, Yellowstone being one of those type of supervolcanoes. So it's kind of a whole caldera that is one of these hotspots type of volcanoes. Okay. The stratovolcanoes means that the volcano actually accumulates. Let's see here if we have. Okay, so here we have that, and over time it goes through a cycle between eruptions of ash, where the volcano is just sending ash on the atmosphere, and it accumulates layers of ash that are not very dense, And then at some points, when the pressure gets higher and there's a eruption of lava, then it sends lava flows, and so it makes kind of thicker layers. Okay, so there you see in the picture, 7 is layers of ash emitted by the volcano, and 9 layers of lava emitted by the volcano. And so depending on what cycle the volcano is on, it would form this kind of a strata of layers. So that is why it's called a stratovolcano. Okay, so does that make sense? All right. Let's see what else could we see. Let's look at a couple of videos here of geysers. So we have here a video of Old Faithful, and this is an interesting geyser because it has a very regular cycle. Okay, every 50 something. Okay, I'm going to close this so it doesn't bother me. Okay, so it has a very regular cycle. I think that is like 56 minutes or something like that, where the pressure of the water in the caldera builds up and then it erupts here in this sprout of water and gas. Usually it's, superheated water that builds up in the caldera. Okay, have you ever had the chance of going there to Yellowstone and seeing these geysers? I have here, there's also a link here to a very good, this is a very good animation, okay, explaining how geysers form, and I invite you to look at that.
At least 3 things to work. The first is a water supply.
Okay, we are not going to watch the whole
shallow
thing,
groundwater or surface recharge,
but it really explains how the geyser forms.
This is not lava or molten rock, but normally superheated water.
So you have cold water source,
high pressure.
then
Finally, a geyser
superheated water source.
As it's heated. This is often a vertical shaft or conduit, perhaps connected to other voids or spaces nearby. This plumbing system needs to be pressure tight. In a geyser, this is due to a layer of mineral, called sinter, that is deposited on the walls of the conduit. Over time, more and more of this sinter may be deposited, sealing the walls and perhaps narrowing channels.
So the sealing of this plumbing system is what makes it so the water accumulates and doesn't seep out.
An eruption cycle starts with the conduit being...
So it really, this video explains very well how the volcano works, all right? A very, very interesting thing. So some geysers are like this one that kind of go into cycles, like Old Faithful. Others are kind of continually bubbling up water. Interestingly enough, I live over one of these type of hotspots, okay, there in Saratoga Springs in Utah, where we have heated water that comes up through a fault, really, that is right there. And the water is very hot. We actually have the only open swimming pool, year-round swimming pool in Utah, okay, because we use the water from the springs, from Saratoga Springs, mix it with regular water to cool it down a little bit, okay, but it's very, very nice. So I'm very spoiled on being able to live in such a great place, frankly. Okay.
Yeah. Could I tell you a story about when I went to a geyser field?
Please, go ahead.
Thank you.
Yes.
So, for Boy Scouts, we decided to go up to Yellowstone, up by Sumner Lakes. And we canoed up there, and canoed and kayaked, and I got up there and we drug our boats on shore, and as we're walking through this geyser field, it was really cool. You see all these bubbling water. It's great to touch it in the water because it's warm. You have to be careful. But there
Yeah,
was
you
since
never
there
know
was
how hot it is. So
yeah, we were joking because it was out in the middle of nowhere. You had a canoe or a hike 30 miles there or so. No one was nearby, and as we've gone through the whole thing, it was really cool to see the bigger ones. They were crystal clear, and you could see 20 feet to the bottom. There'd be an old canoe sitting there. But on the way back, there was this one geyser I didn't get to look at, and I was at the back of the line, and it was lunchtime, so I was feeling hungry, and I saw it, and I'm like, oh, let's go look at that one. And I'm like, nah, it's going to take time, I'm hungry. Let's just go to lunch. So the moment I pass it, it erupts and shoots boiling water right up. And I'm like, ah, look! And everyone turns back, what, oh, wow! And just pulls down and they looked, but still. I avoided being singed with boiling water just because I wanted to eat lunch instead.
wow. So you were right there in the spot where the geyser would actually go off and spew the hot water on.
Yeah, I went up about 10, 15 feet. We were about 10 feet away from it, walking away when it went off.
So where was that exactly? Was it in Yellowstone area?
It was Yellowstone, Lake Shoshone, I think.
Uh-huh.
Shoshone Lake. There's a little geyser field. There was hundreds of little geysers all over. That was one of the bigger ones. And it was a mound. And it shot off like a volcano and boiling water. And I was sitting there going, I turned to my scoutmasters and like, luckily I decided I wanted lunch instead of looking in that one because that would have hurt me really bad.
Wow, yeah, you were really safe from that.
Yeah.
That is cool.
Glad I didn't look at that one.
Yeah.
But I mean, it's boiling water. You see it bubbling and evaporating as it comes out. So
that's right.
You gotta
Yes.
be around them, but
Yeah.
they are really cool.
Yeah,
One
very
side,
cool. And
I
in fact, some of the geysers, the water is actually even superheated. So it is actually, even though it comes kind of as a plume of water and vapor, is actually even hotter than the boiling point. Okay, because it kind of accumulates under pressure, and that even raises the temperature more. Mm-hmm. Okay.
Yeah.
Yeah. Well, yeah. Be careful.
Careful. It's kind of interesting where we went. There was no signs warning to go close to the geysers until the end of the hike.
Oh, wow.
Like at the very end, there's one tiny sign about 10 inches across that says, don't go near them. And it was on the ground, on a log, at the end of the hike.
Wow.
Dang. So,
yeah.
I'll let you get to know that. Good story to remember to listen to the Holy Ghost. They really...
No kidding. Yeah, yeah.
Moment of trial there.
No kidding, yeah. See, also here, as you can see here, I'm zooming back into this area of Hawaii where this lava flow is. And for some reason, this was actually completely developed. Okay, so where you see these few houses here and there, I have no idea how some of these houses actually survive. Okay. But the interesting thing was that this whole area was completely developed. And when the lava flow happened, it literally obliterated everything and it left some homes standing. Okay. I don't know that I don't think that these homes were built before the lava flow. It seemed actually that they were built after. I mean, they were built before the lava flow. Okay, but I don't know how they survived. Most of them were for sale, I noticed. I don't know who would want to actually build on a lava field, you know. But I guess some people did. I guess that these people are actually thinking, well, maybe the flow has already passed. Okay, you know, now it's going to move further east, you know, and form more land over here. I guess that's the gamble that they are taking. Hmm. So, Benjamin, what is your take on living so close to active volcanoes? How does it feel for you? Okay. So the owners probably had a special mission for God. Yeah. Yeah. So this wasn't homes on a hill. They were really literally in the middle of the lava flow. Hmm. So what? No one wants to live on an active volcano. It's interesting, as I was mentioning early on about this issue. Okay, um, nearly flows into the lava stream. Yeah. Okay, it's pretty cool. Okay, might be fun. You prefer, Emma says, I prefer not to burn to death. So, do people there in Hawaii ever, the people that live there in Hawaii, Benjamin, do they think much about the volcanic activity going on, or is it just, a fact of life and no one thinks much about it? Hmm. So Benjamin says yes. Okay. If it's on a hill, I could just watch it peacefully go by. Hmm. So the lava doesn't flow very fast, all right, especially this one. They think much about it. So Benjamin says that they do think about it. Okay, one thing that I want to tell you, if you're going to do the chatting and it's something related to the class, it's actually better if you just do it to all the class. If you want to ask me something specifically or send me a comment, then you can do the private chat, okay? So really living on the edge. So yeah, all right. One of the things, so the volcanoes and the volcanic activity, do you know that you can actually drink lava only once? Yes, only once. I don't know that anyone would want to try that once. So, because you can only do it once. So, that is one of the interesting things, as I was saying, is that because of the fertile land that the volcanoes create, it's interesting that there's lots of people living close to volcanic areas. So see the area of Japan, okay, the Korean, the Kamchatka Peninsula, all right, the Ring of Fire, all the area in Central America, even here in South America, and of course the area here in Europe, in Italy, where you have volcanic activity. This part also of Africa has quite a bit of population. Indonesia, millions of people live right there by the volcanoes, and because of the volcanoes provide this rich soil where they can actually cultivate the land. Okay, so it is an interesting thing how people have this kind of love-hate relationship with volcanic activity. Okay, you have also that geysers, and volcanoes produce geothermal plants. So in Iceland, they actually harvest the heated water and they produce electricity and energy that they send throughout the island, okay, from the volcanoes. So everyone knows that you are living really there on the volcano. Mm-hmm. Okay, so that is kind of one interesting feature of that. Another interesting thing that is kind of the concept here about the class is that you see that volcanoes are one of the ways in how the earth changes. It kind of is a way of how the earth renews itself. Okay, the gospel principle that we can glean from that is that the gospel of Jesus Christ is really a constant thing in a changing world. Okay, so what are some of the things that change in the church, and what are some of the things that remain constant in the kingdom of God? All right, that is something that I want you to actually think about. And I have for this lesson, I ask you to complete one of these two assignments. So we have an activity and an assignment. The assignment is for you to teach the family home evening, discussing with your family, okay, these questions, and then writing a report of what you learned from this experience. Okay, so the questions that I want you to consider are: in what ways does the earth remain the same? Okay. Prophets change from time to time, so that is one of the ways that the church changes. It changes the leadership slowly, okay, but it changes. So in what ways does the earth remain the same, and in what ways does the earth change? That is interesting to think about. And also, in what ways does the church change? Like Rodney was saying, the prophets, they change once in a while. And in what ways does the church remain the same? What are the things that we can learn from that? Okay. And you can do that as a family home evening activity. I think that would be an actually very interesting family home evening that you can do with your family. The activity, this is also, who was last time? I think that it was Abigail that says, are we going to make a volcano? So I'm going to ask you, if you want to do this activity, to do something kind of similar than a volcano, all right? You have probably already done the volcanoes experiments and everything. And if you want to really do that, okay, you can do it with your younger siblings and everything. You have here in the family school some of the instructions on how to do that, okay? But the activity that I have for you is use a Pyrex glass pot, okay? Something that would be heat resistant, all right? And that you can see the sides, all right? That would be the ideal. If you cannot do that, if you don't have a Pyrex glass pot, then you can do it on a metal one. But what I want you to do is to prepare some oatmeal, okay? Don't make it too thick. Make it kind of, a runny consistency of oatmeal, all right? Then you turn the heat on as you start preparing the oatmeal. And when the oatmeal is hot but not yet boiling, put on top carefully a layer of tomato sauce. Okay? So we are going to make some oatmeal tomato sauce mix. Okay? So the oatmeal is going to represent the earth mantle. Okay? The tomato sauce is going to be the crust. All right? Okay, in fact, if you want, you can put on top of the tomato sauce some layers of paper, some pieces of paper cut, okay? And then keep the heat on and observe what is going to happen. You may want to be ready to even take some videos or pictures of that and then write a report of the experience, okay? What you saw, explain what happened, okay? And compare that with what you are learning with volcanoes and geology. All right? So, what do you think about that activity? Would that be something fun to try? So, kind of, this will be a slow moving volcano, okay? So we don't want any explosions or anything like that, but let's give it a try and see what you come up with, okay? I'm dying to see what you can film or the pictures that you can take on that, okay? So remember, you need to complete one of these, either the assignment or the activity, and submit that. Remember that we are going to have you complete an assignment per lesson, okay, from here to the end of the year. All right, and then I'm going to prepare a quiz, okay, and publish the quiz as soon as possible on this lesson. The quizzes are easy if you have listened to the lesson and done the readings and so on. You won't have any problems. All right, so that is the class for today. Thank you very, very much for participating. And let's finish with a prayer. Who would like to offer a prayer for us? Okay. Benjamin, you live in a beautiful, beautiful place. Hawaii was just amazing. Okay, Rodney, would you like to pray for us, please?
Yep.
Thank you.
Our dear kind Heavenly Father, we're thankful for this day. We're thankful that we're able to meet over the internet and we're able to learn together. Please help us to be able to learn and experiment on our own and be able to pattern ourselves, that we may be able to be learning always. Help us to overcome our weaknesses and our failings. And these things we pray for in the name of thy Son, Jesus Christ. Amen.
Amen. Thank you very much. Thank you. Let's see. Benjamin says, some people here think that if you try to change the lava paths, you make Pele mad. Okay. Yeah, I don't think that it would be a good idea to try that. Okay. So, things are how they are because of a good reason. So thank you everyone for your participation, and we'll see you next week.